Hello, Maurieo does maths. Trig problems. Hello. Welcome. Well, as part of this mathematical video, we're going to solve the problem below. Solve 5 cos 2 theta plus pi upon 3 equals 4. Over the range 0 less than or equal to theta less than or equal to pi. So let's just pop over to the big screen here where we've got it all set up, and let's see what we can do using Smooth Draw 4 and our calculator. So first up, you can see here we've got this thing. What we're going to do is we're going to just make it a little bit easier. Let x equal 2 theta plus pi upon 3. Okay, so we're going to let that equal x. So then we can go 5 cosine x, which of course equals 2 theta plus pi upon 3, equals 4. So now we're just dealing with x. We're not dealing with all this carry on here. So what we're going to do now is we're going to divide both sides by 5, and what we end up with is cos x cos of x equals 4 upon 5. And of course now we can solve that by going cos to the negative 1, 4 upon 5 equals x. So now that means we go across to our calculator here and just make sure that we've got the mode, shift mode, try it again, shift mode, make sure it's in radian mode. 4, we're working in radians now. Okay, now we can go shift cosine, and I'll just put it in here as a fraction, 4, and we'll zip down to there upon 5, come back here, close the bracket, equals, and we'll just show that to 0.6435. so here we've got x equals 0.6435. Okay, now this is on the cosine graph, so we'll just try and draw a cosine graph in here, something like this here. Okay, so that would be 0 in there. That would be pi by 2, pi, 3 pi by 2, and 2 pi up here. Okay, and then it ranges, so we could have a different color. Here we go. We can put a different. So we can put the. We know that the graph ranges between 1 and -1. So we can, now the cosine graph comes like this. And there's the blue there. It comes down to there. Oh, up to there. A bit wonky. Like that. So that's our cosine graph. Now our value that we've got here is 0.6435. So it's going to be somewhere in here. Oops, that didn't. We'll just do it in the magenta there. So that's it there. 0.6435. That will be there, and there'll also be another one here, like if we draw it through there. Not very good to scale, but as you can see, there'll be another one there. Okay, and then there'll also be, so we'll just continue that on in blue. This here will continue on around here. The graph will, and so there'll be another solution. Another solution here. Okay, so they've got this solution here, this one here, and this one here on the graph. But what we need to do is to check that these solutions are in this range. So this solution here is 0.6435, and that's going to be, well, that's going to be 0.6435, and that's going to be when that's going to be there. So let's have a look at that solution. Oh, well, let's look at this solution here. So this solution here is going to be, this one here is going to be 2, and this is going to be 2 pi minus 0.6435, this one here. So this one here is going to be, so we look at the solutions, 2 pi, here's 2 pi here, okay, and it's going to be minus 0.6435. Okay, 0.6435, because that's going to be what, that distance there, and it'll be that same distance there and that same distance there, either side of the peak. And then this solution here will be 2 pi plus 0.6435. And these are solutions for x, but we want to have a solution for theta. So now we're going to go over to here, and we're going to say, right, we'll look at this selection here. So what we're going to do is, oh, well, what color could we, oh, we'll maybe go back to red. Go back to red there. Okay, so what we're going to do there is we're going to say 0.6435, which is x, equals 2 theta plus pi upon 3. And what you'll find is that then equal, so now we've got to solve that for theta. So we've got 0.6435 minus pi upon 3 equals 2 theta. And then we'll divide through by 2. I didn't have room to put the pi by 3. I could put that up here like this, minus pi by 3 to both sides. Like so. And so what we get is we put that over 2, and that there over 2, and then we get theta equals, so we'll do that on the calculator. So let's just clear everything here. So we've got 0.6435. Oh, hang on, all clear. It's a fraction, so we'll start with a fraction here, and we'll get 0.6435 minus, and we've got another fraction here, which is pi upon 3, like that there, and we'll move right on, and then that'll drop down there. So 0.6435 minus pi upon 3 divided by 2 equals, and that gives us minus 0.20 minus 0.2018 minus, and that is our Q value, but that is outside of the range. That is outside the range. So that's outside the range. So that's no good. And that's outside of the range. So that's not a solution because it's outside our range. That's for theta is minus 0.2018. So what we've got to do now is let's look at our next solution, which is, and that we'll put that down here. So that's going to be 2 pi minus 0.6435, and that will equal 2 theta plus pi by 3. And we'll have to do the same thing again. So that's going to be 2 pi minus pi by 3 minus 0.6435 equals 2 theta. And we'll just do the same process again. we'll divide that all by 2. Divide that by 2. And we'll get theta. And we'll do that on the calculator. So that can come over here. And that'll be all clear. And so that'll be, again, it'll be a fraction. So we'll find out the fraction there. So that'll be 2 times pi, okay, minus, and then there'll be this little fraction here, which will be shift pi upon 3, and then it'll be minus 0.6435 and all over 2. Okay, so let's just 2 times pi minus 0.64, 2 pi times pi minus pi upon 3 minus 0.6435. And that will give us 2.296. 2.296. And yes, that will be in the range, because that's in the range of between 0 and pi, which, remember, pi is, I'll just put that up here in yellow, pi is 3.14. So that's in the range, because in terms of radians, that's 2.96. But there's another possible solution here, and that is the one where that is plus 0.6435. So I'll just do that one. I won't write that one out. I'll try and save a little bit of time on that one. And yep, I'll just write that in here. Okay, so that's going in there, and that'll be theta equals. So we'll just come back up into here, and we can just come back into here, and we'll just make that plus on the calculator, and that's a divide, plus equals, and we get 2.940. So that these here are the two solutions. Oh, my pen went a bit ape there. So that's solution 1, theta equals 2.296, and this is solution 2 here. And these are these solutions here, where x on the x equals there. So just to recap all that, we've got 2 theta, but that's going to be very complicated. So what we do is we let that equal x. Oops. Okay, if we can get. Okay, our brush size needs to come down a bit. Yeah. Okay, so we let that equal x. So we let that equal x in here. Okay, and then our ink flow back there. We let that equal x and work it out for x. So we put x in there, and that it divide by 5, cost to the minus, so that gives us our value for x, 0.6435. So that's a solution of x, which is going to be there, which is this distance here, 0.6435. But when we worked out that one there, we found that it was negative. So it's outside the range. So that's not a solution that we need. So what we've got to do is look at for our next solution, which is up here, and there's two of them here, and this one here is at 2 pi minus 0.6435, because that's it. That's the little distance in there, and that's it there, 2 pi plus 0.6435. So that's for x. So then we have to evaluate each of those, and I've worked this one out in full here, and that will give us the first solution there, and then the second solution where that is plus 0.6435 radians along the thing there. So yeah, that's all very good. So there you go. We've solved that little problem there, and yeah, it's all good to go.